Welcome to today's class. Today's class we are going to majorly introduce another unit which is called Fundamentals of Mathematics or Foundation of Mathematics. This Foundation of Mathematics is a majorly topic which is learned during the introduction of units, and it's applicable across all units because in every unit that you study there must be a mathematic which is applied there, be it any unit, it contains mathematics. So we are going to start dealing with what's a theory of sets. So theory of sets and its application in business. So first of all, we have to go through these terms used in a set and understand them and do the calculations, and they are easy. So let's follow this lesson and everything will be okay. Thank you for joining this class. So we're going to start from what's a theory, a set theory. So a set theory or theory of a set. So before defining what's a theory of sets, let's define what's a set. So a set is a group of distinct and clearly defined items. Okay, so a distinct and clearly defined items, that's what we refer to as a set. So the elements of a set are things, okay, or items. So elements of a set, they are. So a set entails items. In modern mathematics, relies heavily on set theory, which is extensively applied in other academic fields. Or let's now define what theory of sets. It's a mathematical concept of well-defined grouping of objects or sets that are referred to as members or elements of a set. The only sets being considered are those whose members are also sets, because pure theory set only deals with sets. So this theory of sets deals with sets only. So we have two representations of sets. Number one, we have interpolation technique and calculation technique. So let us look what is interpolating technique. Interpolating technique is a form for the set builder method and rules. And calculation technique is a set components I listed one after the other, separated by commas and contained in brackets. So calculation technique, you must have these components that are listed one after the other, separated by commas and contained in brackets. For it to be a set, it must be in a bracket. So for example, we have an example, the formula, like the formula set A. Let's take this as set A. Set A into brackets, then it has those elements there. Is used to indicate a group of natural numbers fewer than 7. Okay, so this is a good example for that case. We have another term we have to understand is a set creator form. Set creator form is by listing a characteristic shared by all of its members. The set is featured or characterized. For example, set A is equal to XX is odd, X12 love is used to denote the correction of odd values less than 12. We have an indicator number. Indicator number refers to how many elements there are in a set. The symbol for it is N. N, it represents name of the set. An example is A. So let's work out this A. Set A is equal to, opening the bracket, elements, then they are separated by commas, then close the bracket. So therefore, the name of the set A is equals to 3. how there are 1, 2, 3. There are 3 elements inside this set. 1, 2, 3. So this is where we count. So therefore our number are 3. So that's where we got the answer from. So the cardinal number for A, we have gotten it. Let's look at this B. B will be A, B, C, D, E. How many in this set B, how many elements are there? 1, 2, 3, 4, 5. So therefore the name of the set B is equal to 5. So the cardinal number for B. Okay, so we have a part of a set. So think of a set A where A is equal to A, B, and C. The set, the theoretical notation for the elements A can be written as A, since it's obvious that it belongs to set A. So to understand, as A is a member of the set A. Additionally, since the elements D do not belong to set A, it can be written as D in theoretical notation. So set A to be understood as D doesn't belong to set A. So as easy as that. So let's look at the set order. In the set order, the quantity unique items in a set determine its ranking. So the unique items in a set determines its ranking. So we have a picked set or finite set. If a set has a finite number of items, the set is said to be finite. So if a set has a finite number of items, the set is said to be finite. Why? A finite number is a number which has an end. So if it's finite, it's said to be finite. For example, set A, it has elements 1 to 5. Okay, so it is finite because it's ending. Okay, it has a starting point and an ending point. Okay, so 5 elements make up set A. The set is finite. Then we have an endless set or infinite set. So if a set has an infinite number of elements, the set is said to be infinite. So it's endless, it's continuous. So for example, set B, it has elements which are continuous, like it has no end. So it's written like this. So it's endless or infinite. So B is infinite set if only B has an infinite number of elements. We have a singleton set. A set that is referred to as singleton set if it exactly includes just one element or refers to a single set. For example, we have C. Set C. It has only one element, which is 45. So we can have even D, which has one element, which is, let's say, an element which is 50. So we write it D, set D is equals to, open the bracket, we like to have 50, close the bracket. So just like that. Now you're going to look at the accounts of sets or union of sets. So accounts of set, it means a union. So union, it means coming together. So the union of two sets A and B is C. So the components of C are found in A and B, or both, and are stated as C. So C is equal to A and B. So A and B, when they union, they form set C, or set C is equal to A and B. So the union. So the union is denoted by this symbol, which is here. The symbol which is shown on the screen. So we read it as A union B. So let us union these sets, set A and B. So let us find C. So set A has the following elements enclosed in the brackets, and B the same thing. So in the union of sets, we only pick one element, which is represented once. So if element, let's say one is represented twice, let's say A and B one is represented, we pick one once. So for example, let's work out this one. So C is equals to A union B, which will be equal to 1, 2, 3, 4, 3, 4, 5, 6. So what are the common elements in A and B? A and B will have 3, 4. 3, 4 are common because they are found in set A and set B. So we'll represent them only once. So it will be 1, 2, 3, 4, 5, 6. So A union B is equal to 1, 2, 3, 4, 5, 6. Let's look at the connecting two sets or intersection of sets. So intersection of sets is those elements which sets share. So if two sets A and B cross to form D, then components D are items shared by A and B, which are written as D is equal to A and B. So for example, let us look at the intersection A and B. So intersection is represented by this denotation. So we said that what A and B share is what we call an intersection. So A it has A, B, C, D, and set B it has C, D, E, F. So there are some common elements here, which is C, D in set A, and B, C, D. So A intersection B, it will be C, D. So the idea of a set union and intersection can be applied to any quantity of sets. So that's an application part of it. Let's look at the completion of a set. The set of A elements that are not also in B is also known as complement of B and is indicated by symbol B, then that symbol. So this symbol represents a complement of a set. So when B is a subset of A. So let us look at an example of this. So complement. Let's look for complement B. So we said that our set cannot be complete without brackets. So this set A is not complete. We must insert the brackets as opening bracket and closing the bracket. So this is a complete set of A. And B, close the bracket, open the bracket. So here you are asked to find the complement of set B. So complement of set B, it will be, we said that what B entails, but A doesn't entail, we remove them. So B, what does B entail? B entails 1. So when we come to set A, we'll move that 1 because it's already in B. So the complement of B will be 2, 3, 4. Alright? So the complement will be 2, 3, 4. Yeah, we close the bracket like this. Close the bracket. Yeah, so this is the answer. So B complement is 2, 3, 4. So we can look at another example. More examples we're going to look. class. So we're continuing with the class. So let us look what's a subset. A subset is formed from a set. So a subset is a division of a set. So for example, think of two sets A, B. If every single element in set B is also in set A, then we can say that B falls under set A scope. It can be expressed as set B A, which means that set B is contained in A. An example is this one. What's a subset of set A? So subset of set A, possible subsets of set A, it will be AB and CD. Okay, so we divide a subset, so here we divide it by 2. So the division of elements and this one, so it will be AB and CD. So set B will be AB, and another one could have been CD. Simple as such. So every component of B is a component of A. So that set B must entail what is in set A. Let's look at more examples. Let's find the subset of A. Subset of A will be, or possible subsets of A would be 1 is a subset, 2, 3, or 1, 2, and 2, 3, or 3, 2, and 2, 1. So those are the subsets. So these are the possible outcomes. Said 1, 2, then we said subset A3 equals to 3. So this 3 can be a subset, or this 1, 2, 3 is a subset, or 3, 2, 1 a subset. So as long as those elements entailed in a subset are found in set A, which is the main set, so that's a subset. But it cannot be an empty set. So we cannot call an empty set a subset. And a subset can be, okay, we have identical, equal, or identical set. So if two or more sets have exactly the same items, they are said to be equal or identical. For example, set A is 1, 2, 3, and set B is 3, 2. So A and B are an equation of very equal or identical sets. So they must have equal sets, or the sets must be equal, the elements must be equal. So like this is not an equal set, because the elements in A are 3 and the elements in B are 2. So you cannot say that this is an equal set. An equal set, it would be if A contained three elements and B that contained 3 elements, we could have said that it's an equal set. So A and B are an equation of equal or identical sets in our case. Comparable set. So comparable sets and equivalent sets are those that have the same amount of elements as another set or sets. So for example, A is 1, 2, 3, B is equal to A, B, C. So number of set A is equal to 3. The number of set B equals to 3. A and B are considered to be equivalent sets because number of set A is equals to number of set B. So these are the equal sets. Okay. So these are equal sets, or you can call them. So they are comparable because this one goes with element 1 goes with element A, element 2 goes with element B, and element 3 goes with element C. Disjoint. Set disjoint. Set disjoint. If sets A and B are two sets and neither set has any elements in common, then set AB are supposed to be separate sets. Okay. If set A and B are two sets and neither has any elements in common, so if they have nothing in common, they are separate sets. That's what we call disjoint set. They are not common in both. So let's look at the default set. If a set contains every component of each and its correct subset, it is said to be a universal set. It is represented by letter E. So universal set is represented by letter E. An example. So default set is also known as a universal set. An example is universal set. Universal set here is equals to 1, 2, 3, and set A is equals to 1, 2, and set B is equals to 3. So what is the universal set here? A and B are universal. Why? Okay. So A and B are universal sets. Why? Come to here. If a set contains every component of each of its correct subset, it's also said to be universal. Okay. So A has element 1, 2. So our universal set contains 1, 2, and B has element 3, which is in the universal set. So these are universal sets. So universal sets set A and B both contain what is inside the universal set. So it's a universal set. We have an empty set or null set or set void. A set is referred to as null if it's a deep void of n elements. It's indicated by or. Example is set C. Set C is equals to null. You can see correctly there's nothing inside. So it's an empty set. Set difference or division of a set. Set difference, and the difference between set A and set B refers to a correction of A elements that are linked in set B elements. Set B is indicated by the symbol set A minus B when the bracket close the bracket inside them, and it's interpreted as set A difference set B. Thus, set A difference set B is equals to X, where X is equals to set A, X is equals to set B. Example, if set B is equals to 3, 4, element 3, 4, and set A is equals to element 1, 2, 3. So set B minus set A is equals to 4, 5. How? Let's put first of all the brackets to make it a set. Remember, in every elements they must be enclosed by bracket. Open the bracket, close the bracket. So set B difference A is equal to 4, 5. How? We start here, B difference A. So what's in B, what's in B that is not in A? Okay, here we had 5. So now let's complete now. So what is in B, which is not a variable in A? So it's 4, 5, because 3 is a variable in set A. So the difference is 4, 5, and A difference B become what is in set A that is not in B. So A is equals to 1, 2, 3. So 3 is a variable here, so it's 1, 2. We get the difference. Okay, as simple as such. So we have the Morgan's rule, or rule of Morgan. Rule of Morgan says that A and B can be represented as 1 if there are 2 sets. Okay, so open the bracket is set A union B, close the bracket is equals to set A intersection B, or open the bracket, set A intersection B, close the bracket is equals to set complement A union set complement B. Don't forget this complement. So it's set A union B complement, close the bracket, then complement. So it's equals to set A complement intersection B complement. Okay, that's how it's read. This is a complement, we said, remember. So we have a universal set. The universal set a set contains a universal set that contains items from all related sets without any repetition of elements is known as universal set. Okay, it contains all elements but they are not repeated. Okay, so it's represented by letter. This is the definition of union. Assume A and B are 2 pairs such that set A has elements 8, 9, 10, and set B has elements 8, C, D, E. Then the universal set of these 2 sets is given by universal. It's supposed to open the bracket 8, 9, 10. Then B, this 8 we won't repeat it because I've represented it here, so it is C, D, E, the continuation. C, D, E, yeah, so it's equals to universal set is equals to 8, 9, 10, C, D, E. That's a universal set. It's represented by this a diagram which represents a universal set. It's only represented once. You can see set A, set B, and these are universal. Okay, so here we have teachers. We have set. We have teachers. So this set contains this universal set contains teachers. So we have male teachers and female teachers. Male teachers and male local teachers. We have row of distribution. So law of distribution is defined by set A is equals to set B is equals to set A is equals to set C. Okay, or set A intersection, open the bracket, B union C, close the bracket is equals to open the bracket, set A intersection B, close the bracket, union, open the bracket, A intersection C, close the bracket. So that's the row of distribution. Let's look at those rows. So those rows apply here, the row of distribution. So for example, we have this. How would we read this set? You can say this set A, B, C, but they intersect to each other. So here in the shaded part, this is where they share the common elements see shaded parts. They share the common element, so it's read by set A intersection B. So set A intersection B, you can see the intersect, then union A intersection C, union A intersection C. You can see also A intersects with C. Yeah, but they did not share anything. A does not share anything with A, and C did not share. Another example. Let's write description of A, B, C. These are sets. Then here, B and C, they are sharing elements completely, but A is not sharing completely. They only share on the section side. So here we read B union C, because they share everything completely. B union C. So union is a council which brings together. Then see, this other one is set A, B, C. So it's how is it read? It's set A intersection, open the bracket, B union C, because B and C, they share elements. Those are few examples. Let's look at the final examples, 2 examples. So this was A intersection C, A intersection C. You can see clearly. This is our intersection where it's a shaded area. And this one is A intersection B, A intersection B. This shaded area is where they intersect. Let us look at the last part, which is the basic set operatives. The following are set fundamental operations. So sets are united. We have seen that how sets are united. Sets intersection, we have seen how they intersect. Set difference, we have seen that. Set complements, we have seen that. And the union of sets, we have seen that. Okay? So let's look at the union of sets mathematically. So the union of two sets A and B is C. The components of C are then found in A and B, or both, are written as to as C is equals to A and B. So you can see the components of A and 1, 2, 3, 4, and the B set B elements are 3, 4, 5, 6. So the union, how we're going to represent them is, we represent an element once. So an element must appear once in the union. So and an element must not miss. So yes, 1, 2, 3, 4. 3, 4. 3, 4 is represented, we cannot represent it again. So 5, 6. So it will be 1, 2, 3, 4, 5, 6. So A union B is equals to 1, 2, 3, 4, 5, 6. Intersection. Let's look at the intersection. If two sets A and B cross to form D, then the common name D are items shared by A and B, which are written to us D is equal to A and B. For example, set A, it has A, B, C, and D, and set B, it has C, D, and F. So here, what do they share? It's equal to C and D, and C and D. So A intersection B is equal to CD. We close it by the bracket and open it with bracket. set difference. The set difference between set A and set B refers to the correction of set A elements that aren't set B elements. So B is written to as set A difference B, or indicated by the notation A minus B. So therefore, set A difference B is equals to, open the bracket, x equals xx, then A, then x equals to the notation B, or set A difference set B is equals to x, where x is equals to A and x equals to B. An example is set A it has 1, 2, 3, and set B it has 3, 4. So the difference of set A difference B is equals to 1, 2. Why? We said if we have the difference between set, we read it as from A difference B. So we come A, we say what elements are in A and what elements are in B. So those elements that are in A that are not entered in B, that is the difference, and that's the answer. So elements in A are 1, 2, 3, and elements in B are 3, 4. So elements which are in B are 3 when we come to set A. So we want 3 and 4. Let's put 3 and 4. Okay, for it to be a set. So set A difference B is equals to 1, 2. Why? Because 3, 4 is found in set B also, so we exclude it. Okay. So, and difference B, A, we come to B, A, we come to B. We say what is in B that is not in A. Okay. So B, we have 4, and A, so let's work it out. BA. A. B. What is entailed in B does not in A. Let's say, for example, we have 5. Okay. So yeah, the answer will be B, A. So there will be 3, 4, 5. So between 3, 4, 5, is it entailed in A? We have 3 here, we have 4 here, but 5 is not there. So it is 5. Just like that. And we have completed this one. Set complement. Mathematically, when set A and B are subsets of each other, the set of elements A that does not also belong to B is known as the complement B. Stands for complement of B. So the complement is denoted by this, as we had seen earlier. So an example is this one. Set A plus 1, 2, 3, 4, 5. Set B plus 1, 2. Then the complement will be what's not entailed in B but is present in A. So what is not entered in B? 1, 2, 1, 2 is entered in A. 3, 4, 5 is not entered in B. So that's a complement set of D.